So the last time we did a video, we were talking about 1 and 2 step equations and how we solve them. And today I was going to do 2 ed puzzles for this week, but I feel like we could get it into just one. Because today we're going to talk about how to solve multi-step equations. And then we're going to talk about how to solve multi-step equations with variables on both sides. So we're going to start with solving multi-step equations. When we're solving a multi-step equation, there's a couple steps that we can follow. One, we want to distribute if necessary. We want to spell distribute right because that would be necessary. We want to distribute if we can. If ness, I can never remember. I think it's 1C, 2 S's. Number 2, we'll want to combine our like terms. And then we want to solve, right? We want to make sure that the variable is the only thing left on one side of that equal sign. That's really what solving is, right? It is just to get that variable all by itself. So if we look at some examples, say I've got 9x plus 1 minus 7x minus 5 equals 20. It equals negative 20. Why? Because that's what my paper says. It says negative 20. When we're solving an equation like this, the first thing we'd want to do is distribute, but there's nothing here in parentheses. So we don't need to distribute. So it says if necessary, and in this case, it's just not necessary. So we're going to start off with combining our like terms. And if you'll notice, we have a 9x and a 7x, and those are our like terms. So we've got 9x minus 7x, which would give us 2x. Then over here, we've got 1 minus 5, right? Well, that is negative 4. And we've got all our like terms on this side of the equal sign taken care of. And so we could just go back to setting it equal to negative 20. And now we're in a really good position to solve, right? And in this case, we could actually use a 2-step equation to solve this problem. We could start by adding 4 to both sides because we're undoing everything that's being done to x. Right now we have this 4 being subtracted from it, so we're going to add 4 to both sides to move it over. And we would be left with 2x equals negative 16. And then the only thing we have left on this x is the 2 that's being multiplied to it. When we have a 2, when we have any number butted up against a letter like that, it means multiplication. And so we're going to go ahead and divide both sides by 2. And we can do anything we want to an equation as long as when we do it to both sides. And so these 2's will cancel. 2 over 2 is just 1, and we are left with x. And negative 16 divided by 2 is negative 8. And so we have solved this multi-step equation, right? Whenever we get that x by itself, we know we've got our solution. Let's look at another one where we're actually going to have to do some distribution. What if I have 91 equals negative 7 times the quantity 3a minus 1. So here I have this negative 7 butted up against that parentheses, which means that we have to distribute this time, right? We don't have everything all multiplied out. Nothing we can do with this 91 right now. So we're just going to rewrite it as 91 equals. And then we're going to go negative 7 times 3a. Well, negative 7 times 3 is negative 21. And so we'll have negative 21a. But we can't just multiply it times the 3a. We also have to multiply it by each piece in the parentheses. So now I have negative 7 times negative 1, which is positive 7. And so our distribution portion is done. We could combine like terms, but there are no like terms on any one side to combine. This has an A, this doesn't. I can't combine them. 91 is nothing else on that side. And so now we're ready to solve for A. So I would start undoing everything that's being done. Think of it in terms of opposite PEMDAS, right? Normally we do addition and subtraction last when we're doing order of operations, but because we're undoing what's being done to that A, we kind of go backwards with it. So we're going to go minus 7, minus 7. And if I subtract 7 from 91, I get 84 equals negative 21a. Our last stop, right? The last thing that's being done to this A is that 21, that negative 21 that's being multiplied to it. And so the way we do that is by doing the opposite of multiplication, and we divide it by negative 21. But we have to divide both sides by 21 or we mess with the equality, right? It stays equal as long as we do it to both sides. Now 84 divided by negative 21 is going to be negative 4 equals A. Let's look at something a little more complex, and then we will move into variables on both sides. Let's use the pink. So if I have, let's get really crazy, negative 3 times k minus 8 minus k plus 5 equals 23. When I look at this problem, I see multiple steps, but we're going to do it a little at a time. Again, we're going to start with our distribution. We've got negative 3 times k, which is negative 3k. Then we're going to go negative 3 times negative 8. Well, that's plus 24. Now, you might think this is saying minus this, but when we think about it, this minus, if you remembered when we were adding things like this together, that we had to distribute this negative to each piece, and it would just change the sign, and then we could pull it out. So if I distribute the negative to k, I wind up with negative k. And if I distribute it to the plus 5, I wind up with negative 5. And all of this will still equal 23. And what that distribution allows us to do is it allows us to combine those like terms. So now I can look at my k's over on this side and I go, well, I've got minus 3k and I have minus k. So minus 3k minus another k is minus 4k. And then I've got 24 minus 5. Well, that's plus 19. And I get equals 23. And now we're in a position to solve, right? We've gotten all our like terms combined. And now we just have to undo everything that's being done to that k. So we would start by subtracting this 19 from both sides. And when I subtract 19 from 23, there's my minus 4k, I get 4. When I divide out that not negative 4, right, the only thing left being done to that k is it's got that negative 4 being multiplied to it. So we're just going to divide by negative 4 on both sides. And I get k equals, well, 4 divided by negative 4 is just negative 1. And so we have found our solution. And so we can do these multiple steps, right? We just need to kind of understand the order of how to do them. Distribute first, combine our like terms, and then solve for our variable. When we're talking about, in all of these circumstances, we only had variables on one side of the equal sign, right? There's no x's on this side. There's no a's on this side. There's no k's on this side. That's not always going to be the case. Sometimes we're going to have those variables on both sides, right? So what happens when we have to solving multivariable, I don't want to say multivariable because it's not multivariable, multi-step, solving with variables on both sides. So our steps for that, again, we're going to distribute if necessary. Then we are going to combine like terms. We're going to move the variables to one side or the other, right? We want all the variables on the same side. Move variables to one side. I always like to move them to the left, just so that when I'm done, I have like x equals, but it doesn't matter which I do. And then we're going to solve. So let's look at what that looks like for us. If I have, for example, 5y minus 8 equals 3y plus 12, the first thing I'm going to do is I'm going to look for something to distribute. And there are no parentheses in this, so we don't have to do any distribution on this problem. So then we're going to look on each side of the equal sign and see if there are any like terms I can combine. Well, I have an fy and I have a -8, which doesn't have a y, so I can't combine anything on this side. And I have that same issue on this side. I've got 3y and I have 12, but none of those can be combined together, right? I can't combine a y, something with a y, to something without a y. And so now we're going to move on to step 3, where we're just going to move the variables to one side. And so I have 5y on this side and I have 3y on this side. I'm going to move this 3y over here. I'm going to go minus 3y minus 3y. I have a positive 3y. If I subtract 3y, I can move it. Here I've got 5y minus 3y. Well, that's 2y minus 8 equals 12. And so now all our variables are on one side of that equal sign. And so we're able to just start undoing. We can just solve now. We can undo everything that's being done to that y. So I'm going to start by adding 8 to both sides. And I get 2y equals 12 plus 8, which is 20. And the only thing being done to that y still is it's got 2 multiplied to it. So I'm going to go ahead and divide both sides by 2. And I get y equals 10. So you just have that one extra step now, right, where we have to move the variables to the other side. Let's look at another is not a word. Another example of that. Let's look at one where we have to distribute. Don't I have any problems where I have to distribute first? All right, here's one where I have to distribute first. So if I have 3 times 6p minus 1 equals 11p minus 45. First thing I'm going to do here is I'm going to distribute because I do have a parentheses. So I'm going to go 3 times 6p is 18p. I'm going to go 3 times -1 is -3 equals 11p minus 45. So I've distributed. And so now I would combine my like terms, but I don't have any combinable like terms on each side of the equation, right? This is an 18p minus 3. They don't both have a p component, so they can't be put together. Here on this side, I have 11p minus 45, and I have the same issue. One of them has that variable and the other one doesn't. So they can't be combined any further. And so now we're just going to start moving our variables to one side. So again, I like to go to the left. I like to have my variables on the left. So I am going to move the 11p over to the other side. It is a positive 11p, so I can move it by subtracting 11p from both sides. Notice how I line it up under the p terms so that I can subtract it easily. Right? I wind up with 8. That's not an 8. Oh, that's because I don't want 8. 18 minus 11 is 7. So I have 7p minus 3 equals now -45. And so now we have all our variables on one side, and all we have to start doing is undoing everything that's being done to that p. So we're going to start with this 3 that's being subtracted from it. We're going to add 3 to both sides, and I'm going to wind up with 7p equals -45 plus 3, which is -42. And our last bit that we have to do is we have to get that 7 that's being multiplied to the p off of it. So we are going to do the opposite of multiplying, and we are going to divide both sides by 7. And we will be left with p equals -6. So I hope that was helpful. You will have one problem to do at the end of this ed puzzle, but your regular assignment will be in Delta Math. Please let me know if you need any help. I'm happy to do it. Send me an email, smoke signal, whatever it takes to get my attention. And I'll be happy to go into a Google Meet with you and help you in any way I can. Hope you have a good week, and let me know how it goes.